Okay, we're going to solve some double angle formula trig equations. Okay, so remember that sine 2x equals to sine x cos x. That's given to you in your formula sheet. And cos 2x is equal to 2 cos squared x minus 1. It's also equal to 1 minus 2 sine squared x. And it's also equal to cos squared x minus sine squared x. Okay, the top two for cos 2x tends to be the ones that we use more often. Okay, so let's get straight into integration. First one is to solve cos 2x minus 5 sin x plus 2 is equal to 0. Now we're going to use one of the cos 2x expansions, and the reason being is because there's another trig term in the question. So our approach at this point is to try and get everything as cos or everything as sine. Well, if cos 2x appears with a trig term with sine in it, then we use 1 minus 2 sine squared x. So cos 2x now can be written as 1 minus 2 sine squared x. Get minus 5 sine x plus 2 is equal to 0. That can now be written as minus 2 sine squared x minus 5 sine x plus 3 is equal to 0. I can then multiply through by minus 1. That will change all signs to give me 2 sine squared x plus 5 sine x minus 3 is equal to 0. Now I can now liken that to 2x squared plus 5x minus 3 and factorise that. So two numbers that multiply give minus 6 and add together to give 5. It's minus 6 and 1. I can then take out a common factor here of 2, so that's going to bring that down to x minus 3 bracket 2x plus 1. I've used the substitution of x or sine x, but I can bring that back in now, and that'll be sine x minus 3 bracket 2 sine x plus 1 is equal to 0. Okay, there's a slight mistake there. That should be plus 6 and minus 1 to add together to give plus 5. So it'll be plus 3 and minus 1. Okay, I can then put a line down the page, and I've got sine x plus 3 could be equal to 0, or 2 sine x minus 1 could be equal to 0. Okay, sine x equals minus 3 has no solutions, since sine x would need to lie between 1 and minus 1. Okay, so that's that bit done. Okay, so over here we've got 2 sine x is equal to 1. Sine x equals 1 over 2. So the question is looking for solutions between 0 and 360. So x equals sine inverse 1 over 2. So I'm going to put on the cast diagram, and it'll be in the all quadrant and the sine quadrant. And that's 30 degrees for the all quadrant, and 180 take away 30, 150 for the sine quadrant. Final answer 30 degrees and 150 degrees. Okay, let's try another question. This time we've got 3 cos 2x minus 10 sine x plus 1 is equal to 0, and I'm looking for solutions that lie between 0 and 360. Okay, so I've got cos 2x and another trig term which is sine. So again, I'm going to use cos 2x equals 1 minus 2 sine squared x. So that will be 3 lots of cos 2x will be 3 lots of 1 minus 2 sine squared x, close the bracket, minus 10 sine x plus 1 is equal to 0. So that will be 3 minus 6 sine squared x minus 10 sine x plus 1 equals 0. Okay, so that's minus 6 sine squared x minus 10 sine x, and 3 plus 1 is 4 is equal to 0. Okay, so I can now multiply through by -1, that'll give me 6 sine squared x plus 10 sine x minus 4 is equal to 0. Okay, so let's take this to the side and liken it to 6x squared plus 10x minus 4 is equal to 0. Remember that the first rule of factorising is to take out a highest common factor, so from 6, 10, 4, I can definitely take 2, so that would be 2 bracket 3x squared plus 5x minus 2 is equal to 0. Then divide both sides by 2, which would give me 3x squared plus 5x minus 2 is equal to 0. I'm making a substitution there of x or sine x, so I can bring that back in now after I factorise it. So two numbers I multiply give -6, and add together I give 5 is going to be 6 and -1. So it's going to be 3x plus 6 bracket 3x minus 1. Can then take out a common factor of 3 there, so that'll be x plus 2 bracket 3x minus 1 is equal to 0. Okay, bring that back in, and that'll be sine x plus 2 bracket 3 sine x minus 1 is equal to 0. Okay, I can then put a line down the page. Sine x plus 2 is equal to 0, and 3 sine x minus 1 is equal to 0. Sine x is equal to -2, which has no solutions. So I can press ahead with this one. That'll be 3 sine x is equal to 1. Sine x equals to 1 over 3. Cast diagram. And I'm going to be all in the sine quadrant. So with your calculator, sine inverse 1/3. And that'll give me 19.5 degrees, and in the sine quadrant it'll be 180 to take away that, which will be 160.5 degrees. Okay, let's try another, which will be 5 cos 2x minus cos x plus 3 is equal to 0. And I'm looking for solutions that lie between 0 and 2 pi, so in radians this time. Okay, so this time I've got cos 2x and another trig term in the question, which is a cos term. So this time then I'll use cos 2x equals 2 cos squared x minus 1. So it'll be 5 lots of 2 cos squared x minus 1 minus cos x plus 3 is equal to 0. That's 10 cos squared x minus 5 minus cos x plus 3 is equal to 0. Let's tidy that up, so that's 10 cos squared x minus cos x minus 2 is equal to 0. Okay, and at the side I can liken that to 10x squared minus x minus 2 equals 0. I'm looking for two numbers that multiply give -20, I together give -1, which is 4 and -5. Okay, so that will be 10x plus 4 bracket 10x minus 5. I can then take out a common factor of 2 here and a common factor of 5, which will bring me down to 5x plus 2 bracket 2x minus 1. Okay, so I've made a substitution there for x and cos x, so that'll be 5 cos x plus 2 bracket 2 cos x minus 1 is equal to 0. Line down the page, and I've got 5 cos x plus 2 is equal to 0, and 2 cos x minus 1 is equal to 0. So 5 cos x is equal to -2 over 5. Or rather just -2, but cos x is equal to -2 over 5. Okay, we're then going to change that to a positive result, but look in the other two quadrants. So instead of looking in all in cos, I'm going to look in the sine and tan. Okay, so x equals cos inverse 2/5. So if I enter that in the calculator, I'll get 1.2 radians. However, I'm not in the all quadrant, so we cross that out. I'm, however, in the sine quadrant, which would tell me to do pi take away 1.2. So that's 3.14 take away 1.2. and that'll give me 1.94. I'm also in the tan quadrant, which will tell me to do pi plus 1.2, which will give me 4.34. Remember that I'm in radians, so I need to be in radians mode. Okay, so over here I've got 2 cos x equals 1 and cos x equals 1 over 2. And I'll be in all in cos. X equals cos inverse 1/2. Okay, so I'm going to think about the exact values there. That's non-calculator. And cos at half, that will be at 60 degrees, which is pi over 3. But I'm also in the cosine quadrant, which will tell me to do 2 pi take away pi over 3. So think about 2 pizzas split into thirds. That's 6 thirds take away 1/3. That's 5 thirds, 5 pi over 3. Final answer. Okay, let's try another. We've got 3 cos 2t plus cos t plus 1 is equal to 0. And I'm going to solve this between 0 and 2 pi. Okay, so I've got cos 2t plus another trig term, which is cos, so I'm going to use 2 cos squared t minus 1, so that's 3 lots of 2 cos squared t minus 1, close the bracket, plus cos t plus 1 is equal to 0. So that's 6 cos squared t minus 3 plus cos t plus 1 is equal to 0. 6 cos squared t plus cos t minus 2 is equal to 0. Let's go across and liken that to 6x squared plus x minus 2 equals 0. Two numbers that multiply give minus 12, I take give 1. That's 4 and minus 3. Okay, so that will be 6x plus 4 brackets 6x minus 3. Take out a common factor of 2 and a common factor of 3 brings me down to 3x plus 2 bracket 2x minus 1 is equal to 0. That's then 3 cos t plus 2 bracket 2 cos t minus 1 is equal to 0. Line down the page. 3 cos t plus 2 is equal to 0 on this side, and 2 cos t minus 1 is equal to 0 on this side. That'll give me 3 cos t equals minus 2, and cos t equals minus 2/3, which will change to a positive result. And at that point, cast diagram, and I'm in, for cos it would normally be normal cos, but since I've made that adjustment, it's going to be sine and tan. Okay, so t is equal to cos inverse 2/3. Remember that on the calculator mode, there should be radians for this one. So shift cos 2 over 3 will give me 0.8 radians, but I'm not in all quadrants, so I'm going to cross that out. And 3.14 take away 0.8 will give me 2.34 for being in the sine quadrant. Pi take away 0.8 for the tan quadrant, pi plus 0.8, and that will give me 3.94. Over here I've got 2 cos t is equal to 1, cos t equals 1 over 2, and I'll be in all in the cosine quadrant. So that'll be 60 degrees, but in radians pi over 3. And then 2 pi take away pi over 3, which is 6 pi over 3 take away pi over 3, that's 5 pi over 3. Okay, let's try a couple with the double angle sine. Sine 2x equals 2 sine x cos x. Okay, so sine 2x minus 3 sine x is equal to 0. I'm looking for solutions that lie between 0 and 360. Okay, so you use the sine 2x expansion when there's another trig term in the question, and sine 2x, you get it from the formula sheet, is 2 sine x cos x minus the 3 sine x is equal to 0. I then take my highest common factor, which is sine x, that's sine x bracket 2 cos x minus 1 equals 0. Okay, line down the page, I've got sine x equals 0 and 2 cos x minus 1 is equal to 0. X equals the sine inverse 0. Okay, so I'm all in sine, so that will be 0, and then the sine quadrant 180 take away 0, which is 180. I can then get another solution after 360, since sine repeats after 360, and 0 plus 360 is 360, which takes me up to the upper limit. Okay, on this side I've got 2 cos x equal to 1, cos x equals 1 over 2, cast diagram, and I'll be in all in cos x equals cos inverse 1 over 2. Okay, so that's 60 degrees in the quadrant, and the cosine quadrant, that's 360, take away 60, which is 300 degrees, final answer. Okay, next one, I've got 5 sine 2t is equal to 3 cos t, and I'm looking for solutions that lie between 0 and 2 pi, so bring that across. 5 sine 2t minus 3 cos t is equal to 0. So that's 5 lots of 2 sine t cos t, close the bracket, minus 3 cos t is equal to 0. Open that back up. That'll be 10 sine t cos t minus 3 cos t is equal to 0. Highest common factor then is cos t bracket 10 sine t minus 3 equals 0. So line down the page, I've got cos t is equal to 0 and 10 sine t minus 3 is equal to 0. T equals cos inverse 0. So it'll be all in the cosine quadrant. So my exact value there is 90 degrees, but in radians that's pi over 2. In the cosine quadrant that's 2 pi, take away pi over 2, so 2 pizzas, eat half a pizza will leave you with 3 halves. Okay, on this side, 10 sine t is equal to 3, and sine t is equal to 3 over 10. Cast diagram, and I'm in all in sine. T equals sine inverse 3 over 10. And that'll give me 0.3 radians, and 3.14 take away 0.3 will give me 2.84 radians. Final answer.